A parallelogram interlinked with an isosceles triangle. We're interested in the size of TQR, this angle here. Now, whilst it might look a lot like 90 degrees, we definitely should not just assume that. This is not drawn to scale. Instead, let's do some calculations. So in a parallelogram, a little fact to be aware of is that the opposite angles are the same. So this is 50 degrees. This can be proven by drawing a diagonal down and proving congruent that these two are congruent triangles. Or if you understand that a parallelogram has rotational symmetry of order 2, you can just sort of flip it around like this and you can see it has to be the same angle. Right, now we can focus on the isosceles triangle because we've got one of the angles inside it. So this angle turns out to be 112 when you add 50 and 62. If you subtract from 180, it gives 68. And then because these two are the same, we divide by 2. Each one is 34. Importantly, up here is 34. Let's return to the parallelogram. One other fact to be aware of, worth knowing, is that these two are co-interior angles because the parallel lines here, and you can draw a C, which means they add up to 180. That means this is 130. So the answer is going to be 130 minus 34, which is 96. If you haven't learned about co-interior angles, it is worth being aware of, but you could also do it by, again, using the 50s. The remaining angle is going to be 260, 360 minus 100, and then you divide that into 2. I see lots of people using this method. So that must be 260 divided by 2 gives 130. So you can get there that way, but really I'd advise learning about co-interior angles and then you just can do it straight away. Well done.